Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session, we have completed the lecture number 4 of the rotational motion, right? So where we discussed about the moment of inertia again. So in today's session, so our target is going to be the radius of gyration and some questions on the moment of inertia, okay? And we'll also do the concept of how do we find the moment of inertia of the remaining part. So if we cut some part from the given disk or circular part, so then how do we find the moment of inertia of the remaining part? Okay, so that also we'll discuss it in today's session. So chalo, so next 1 hour just be with me guys, avoid all the disturbances around you. So and at the end of the lecture, it's very important to prepare your own short notes. Chalo. So let's start the session with very high positive energy. So let's begin with a simple question. So try to solve this question on your own guys. So what's the question says here? So what's the question says? ABC is a right angle triangular plate of uniform thickness. Okay. So the sides are such that AB is greater than BC. So here this hint is AB is greater than BC. Fine. So next, as shown in the figure, I1 and I2, I3 are the moment of inertia about AB, BC and CA respectively. So then which of the following relations is correct? See, so we discussed about moment of inertia about the triangular lamina. So for the triangular lamina, the moment of inertia I is equals to about its base is equals to mh square by 6. So see, so about BC, so whatever the mass of triangular lamina is there, so about AB also the same mass and about AC also the same mass, because the triangular lamina is same. So that's why the mass is going to be same. Yes or no? So the mass is going to be constant and 6 is the constant. So that means the moment of inertia in this particular case, it's depending on the height. It's depending on the height. Yes or no? So now, about which axis the height is more? So that you have to check. For BC, if you are finding the moment of inertia about BC, so AB will become the height. Yes or no? For BC, AB will become the height. So and then if you are finding the moment of inertia about AB, so BC will be the height. Yes or no? So if you are finding the moment of inertia about AC, so this will become the height. So this will be the height for AC. So let's say for BC, let's say this one. If you are finding the moment of inertia about BC, so the height H1, consider this is a height H1. So now if you are finding the moment of inertia about AB, so this will be the height, right? H2. So the height will be H2. So if you are finding the moment of inertia about AC, so the height will be H3. This is a H3. So in the question they said that clearly the AB side is greater than the BC. AB height is greater than the BC. So here I am writing AB is greater than BC. So which means the H1 is greater than H2. H1 is greater than H2. So that can we write the moment of inertia about BC will be high, so greater than the moment of inertia about AB, then the moment of inertia about AC, because AC will be the smallest height. For BC, this will be the height which is highest. So then moment of inertia will be high, because moment of inertia is directly proportional to height square. So that's why for BC, this height will be the highest. So the moment of inertia about BC will be high. Then for AB, so for AB, BC will be the height. So next AB. So then the least is for the AC, because the AC, the height will be this one, which is least among the three. So this is the correct option. So I can say that about BC means it's a I2 as per the given question. Moment of inertia about BC is I2 here. Moment of inertia about AB is I1. I2 is greater than I1 is greater than I3. So you should search for this option. I2 greater not equal. I2 greater than, I1 greater than, I3. So the second option is the correct. So third no, fourth no. Clear guys? Understood the concept? Chal. So let's move further. Similar question. So let's try to solve this question. Here ABC is a triangular plate of uniform thickness. Fine. So the sides are in the ratio as shown in the figure. So this side is 3, 4, 5. Okay. So IAB, IBC and ICA are moments of inertia about AB, BC, ACA respectively. Which of the following relations are correct? Same question, just they gave the values. So I could say that the height for BC will be AB, which is highest. Let it be H1, let it be H2, let it be H3. Sorry. So let it be H3 height. This is a height H3. So you can see that height H1 is greater than height H2 is greater than height H3. Right? Height H1 is for which moment of inertia? Moment of inertia about BC. Right? Will be greater. So then moment of inertia about height H2 is for about AB. So that then AB. So then moment of inertia about AC. So BC is greater than AC. So AB is greater than BC. AB greater than BC. This option is wrong. BC is greater than AC. BC is greater than AC. This option is correct. So IAB plus IBC is equals to ICA. No. So ICA is maximum. ICA is least actually. Okay. So the option 2 is the correct one guys. Done. Chal. Simple question again. So then the radius of gyration. So the radius of gyration is nothing but let's suppose this is a given body. Now you know the moment of inertia about this axis. Now we search for a same mass. We search for a mass at the same some distance k where its moment of inertia lies. Okay. So that relation is given as, so I is equals to mk square. So where k is the radius of gyration. So here k square is equals to I by m. So then we write k is equals to root over I by m. So the radius of gyration is nothing but, so you had to find its moment of inertia by mass m and square root of it. So that's the radius of gyration. So k is the radius of gyration. So we'll solve the question so that you will understand better. Radius of gyration. Clear this part? Chalo, easy one. So let's move further. So let's take the question number 3 guys. So what's the question says? The radius of gyration of a solid sphere, they said solid sphere of radius r about its tangential is C. So first this is a solid. So this solid sphere has moment of inertia about its axis. So what is about its axis we know. So the moment of inertia about the solid about its axis is going to be 2 by 5 mr square. 2 by 5 mr square. So if it is a hollow sphere, 2 by 3 mr square. Right. So now we need about its tangential. So that means we need somewhere here. Right. So first let's find the moment of inertia about its tangential axis. So this will be at a distance r. So the moment of inertia for the solid sphere about its tangential axis will be equals to, so the moment of inertia about its axis plus the mass into r square. Yes or no? Mass into r square. So what is this one? This we got it as already 2 by 5 mr square about its axis plus mr square. So then we get, so 5 mr square plus 2 mr square, which is 7 by 5 mr square. So this is the moment of inertia about its tangential axis. So now we need the radius of gyration about its tangential axis. We need the radius of gyration about its tangential axis. So how do you find the radius of gyration? So k is equals to root over I by m. So what is the I about its tangential axis we got? 7 by 5 mr square. 7 by 5 mr square by m. So m gets cancelled. So root over 7 by 5. So square root of r square is r. So root over 7 by 5 into r. Hope you guys understood the concept now. So first find its moment of inertia where they are asking. Then So the radius of gyration is nothing but square root of its moment of inertia by the mass m. That's it. Clear? Chal. So let's move further. So the question number 4. So what's the question says here? The ratio of the radii of gyration of circular disc to that of the circular ring. So the radii of gyration of the ratio of the radii of gyration of circular disc to that of the K of disc to that of the circular ring. So is how much? So each of same mass and same radius, and around their respective axis. See here, around their respective axis. So what does it mean by around their respective axis? So if you take for the ring, if you take about its perpendicular axis, for the disc also you should take the perpendicular axis. So let me draw the diagrams first. So consider this is the ring and then this is the disc. So this is the ring and then this is the disc. Okay, so let me take the moment of inertia about its perpendicular axis and passing through the center. So the moment of inertia about its perpendicular axis, when I draw the line like this, it's a perpendicular axis, right? So and about its perpendicular axis here is this one. So above for the ring IR I am writing, which is mr square about its perpendicular axis, right? So and then for the disc, moment of inertia of the disc I am writing, so which is equals to square root of not square root, mr square by 2 about its perpendicular axis, right? So then next I need, so the radii of gyration. So what's the radii of gyration formula? So K of disc by K of ring. So ratio of the radii of gyration of circular disc to that of the ring, disc to that of the ring. So disc formula is root over I of the ring, I of the disc by mass of the disc by square root of, so this is for the ring, so I of the ring by mass of the ring. So they said both have the same mass, so I can cancel out mass and mass. So therefore, so the radii of gyration ratio disc to that of the ring will be equals to square root of ID by IR, square root of disc, moment of inertia of the disc by moment of inertia of the ring. So about its respective axis, for both I took the respective axis as the perpendicular axis, so which is passing through its center. Okay, so square root of ID, what is ID? mr square, and what is IR, which is mr square by 2. So right, so here mr square gets cancelled because they both have the same mass and same radius, so r square also gets cancelled. So it is root 2 is to 1. I can write this as root 2 is to 1. See, for the same question, if you take the respective axis as about its diametrical axis, so then also you should get the same answer. So let me do that process, the method 2. In the question they said respective axis. So here let me take, see, try to understand this concept. For the ring and then for the disc, this is a disc. Now for the ring I am taking about its diametrical axis. For the disc also I am taking about its diametrical axis. Okay, so then the moment of inertia for the ring about its diametrical axis is mr square by 2. The moment of inertia for the disc about its diametrical axis is mr square by 4. So then we got the moment of inertias. So then the K of the disc to the K of the ring we required, right? So which is nothing but square root of, so I by the moment of inertia of the disc by, so the mass m, square root of moment of inertia of the ring by mass m. So mass gets cancelled, so root over ID by I ring. So what is ID? So the moment of inertia of the disc. So what is the, sorry, here the disc only I wrote, right? See, I wrote the formulas reverse, sorry guys, sorry, my bad. Here mr square, for mr square by 2 first I should write. Yeah, here we did the mistake. So here I of the disc by simply I of the ring. So here I of the disk is what? mr square by 2 by mr square. Yes or no? So ring is mr square, right? So mr square gets cancelled. So it is 1 by 2. So which is nothing but root 1 is to root 2. So it's root 1 is to root 2. So not option 1. It's a option 4 is the correct one. My bad. Calculation mistake. Because ID by IR, right? Disk to that of the ring they asked. Disk to that of the ring. So moment of inertia of the disk is about its perpendicular axis mr square by 2 by mr square. Okay. So in this process also you should get the same answer. So for the disk it is mr square by 4 by. So for the ring it is mr square by 2. Yes. So here mr square gets cancelled. So this is square root of this 2 will go up. So 2 by 4. So which is nothing but square root of 1 by 2. So which is 1 is to root 2. So about its perpendicular axis. So here we considered the diametrical axis. In the previous one we considered the perpendicular axis which is passing through its center. So if you consider here perpendicular axis, here also perpendicular axis. So but don't take here perpendicular axis and here diametrical axis. Okay, because they said the respective axis. Done? Clear guys? Chal. So this is done. Next. So let's move on to the question number 5. So what's the question says? The ratio of the radii of gyration of a circular disc about a tangential axis in the plane of the disc and of a circular ring of the same radius of about a tangential axis in the plane of the ring. So try to understand the given question. So the ratio of the radii of gyration of a circular disc about a tangential axis in the plane of the disc. See here. So about circular disc. First let's take circular disc. Circular disc in the plane of the disc. In the plane of the disc means about its diametrical axis. See, if I already know about this one, about its diametrical axis. This is the moment of inertia about the diametrical axis, diameter axis. So which is, this is a circular disc I am taking. So now they are asking about a tangential axis. About a tangential axis means I will take this one. This is a tangential axis. At this point I will take. Sorry. Okay, let it be. So here this distance is taken as r. So we know that the moment of inertia of the disc about its tangential axis, this is the disc, about its tangential axis will be equals to, so the moment of inertia about its diameter, which is nothing but for the disc about its diameter is mr square by 4 plus, so this is mr square. Parallel axis theorem we are applying, same concept. Okay, so this will be 4 mr square plus 1 mr square, 5 mr square by 4. So this is for the disc. Sorry guys. So done this part. Now, so now observe, this is about the tangential axis for the circular disc. So the ratio of radii of gyration circular disc about a tangential axis in the plane of the disc. In the plane of the disc means it's a diametrical axis. Understand that guys. In the plane of the disc. In the plane means diameter will be there in the plane. Either horizontal you take or vertical diameter you take, your wish. And of a circular ring of the same radius about a tangible axis in the plane of the ring. Here also plane of the ring. So let's take the ring here. So this is a ring. So about the tangible axis again we required. So we know about already the diametrical axis and we need here about this point. Right? Chal. So now, so the moment of inertia of the, this is about disc. This is for the disc. And this is for the ring, which is equals to about its diametrical axis is mr square by 2 plus, so this distance will be r, so which is mr square. So now the total it is 3 by 2 mr square. This is for the ring. So now they are asking the radii of gyration of the circular disc to that of the ring. So the radii of gyration of circular disc to that of ring about its tangential axis. So then for the disc means it is id by mass m by, so for the ring means ir by the mass m. So here mass m gets cancelled. Yes. So then the square root of what is the moment of inertia of the disk? So about its tangible axis, 5 mr square by 4. It is 5 mr square by 4 by, so for the ring it is 3 by 2 mr square. It's 3 by 2 mr square. So mr square gets cancelled, guys. So then I can write, so the square root of 5 by 4 into, so this goes up 2 by 3. So 2 ones are 2 twos are. So it is root 5 by 6, which is nothing but root 5 is to root 6. Root 5 is to root 6. Option 2 is the correct one. Clear? Understood the concept? Sure. So clear? So the radii of gyration questions. So what I am giving the homework is, let's write. So take the homework, guys, here. So find radii of gyration, radius of gyration for ring about an axis perpendicular to center and passing through the center, and for the ring about the diametrical axis. Okay, and then so for the disk, so in both about its perpendicular axis and diametrical axis already we solved. So again I am asking you to solve this, guys. So diametrical axis. Okay, so then for solid cylinder, for the solid cylinder about tangential axis, about tangential axis. Simple questions all these are. And then for the hollow cylinder about its tangential axis, about its tangential axis, right? So find these. So take this as a homework. Okay, chalo, simple questions. So now let's move for the next concept, that is, so the moment of inertia of the remaining portion. So what does it mean by remaining portion, sir? So consider this is the disk. So I am taking, so don't write, so again it may become clumsy. So just understand, this is the disk. I am writing this as disk. So for from this disk, so we are removing some part. You are cutting some part. So which is of radius some r, small r, and the total disk radius is capital R, and whose mass is m. Whose mass is m. Okay. So now let the mass of this small, what is the removed part? So the mass of the removed part is m dash. Mass of the removed part is m dash, and its radius is r. And this one, this removed part is at a distance d from the center of the disk. It is at a distance d from the center of the disk. So now what I am asking the question is, find the, so the question, find moment of inertia of remaining portion of disk, of remaining portion of disk about an axis, about an axis passing through center, passing through center and perpendicular to the disk, and perpendicular to the disk. So this is the question. Okay, so we have to find the moment of inertia of the remaining portion about an axis which is passing through the center and perpendicular to the disk, passing through the center and perpendicular to the disk. So the simple formula I'll tell you, so that is the moment of inertia of the remaining part, the moment of inertia of the remaining portion will be equals to, so the moment of inertia of the complete disk, the moment of inertia of the complete disk minus, so the moment of inertia of the removed portion. So the moment of inertia of the removed portion, right? So the first one looks simple. Which one? This is simple. So you know how to find the moment of inertia of the complete disk. So the moment of inertia of the complete disk, whole disk, about its perpendicular axis is equals to, its mass is m and radius is r, so mr square by 2. Mass is m and radius is r, mr square by 2. So you can simply write. But the problem is with the, how do we find the moment of inertia of the remaining portion, removed portion? So the, see, remaining portion means whatever that is left after removing some part. So removed portion means whatever the part that you are removing, so that part's moment of inertia we have to subtract it from the whole moment of inertia of the complete disk. Understanding? So now the question is, what is the moment of inertia of the removed part? How do we calculate? See, in this disk, so the total mass is distributed over its area. The total mass is distributed over its area, so that, shall I say, its mass density, which mass density? So areal mass density, which is equals to, so the mass per unit area, because its whole mass is distributed over some area. So the complete mass density, so the areal mass density, sigma is equals to mass upon area, right? So which we can write it as sigma is equals to mass of the whole disk is m and whole disk has radius r, so that its area will be pi r square. Okay, so now come to the next part. So that is, so how do we find the moment of inertia of remaining removed part? Moment of inertia of removed part. Try to understand clearly, guys. So just only some standard questions will be there on this concept. Okay, so if they ask, they compulsory ask the questions whatever that we are going to do. Not exact questions, same type of questions. So this will be the, let's suppose this is a removed part, so which is at a distance, this is of center. Consider this is the center. From center it is at a distance some d, and then whose radius is smaller, and this one capital one has a radius r, and this one mass m. So now let's consider the mass of the remaining portion is m dash. Let's consider the mass of the remaining portion is m dash. Now if you know the mass of the remaining portion, then you can find the moment of inertia of the removed part. Yes or no? So how do we find that? Simply, so the mass of the removed part, let it be m dash is the mass of removed part. So now I try to understand clearly here. So the total mass m has a moment of inertia sigma. So what is sigma? Mass per unit area. Sigma is equals to mass per unit area. What is this one? Mass per unit area. Don't get confused, just understand clearly. So mass per unit area. So that means per 1 unit, so the mass sigma. So for 2 units it's going to be 2 sigma. For 3 units it's going to be for 3 sigma. Yes or no? Understanding, guys? So now for the mass of so m dash, so it's going to be m dash sigma. Its moment of inertia will be so m dash sigma. Yes or no? So simply, shall I write? So just a minute. Sorry, guys. So now, so the mass of the remaining portion is m dash, right? So then its moment of inertia, mass per unit area. See, sigma is a mass per unit area. So per 1 unit area, it's going to be sigma. For 2 units, it's 2 sigma. For 3 units, it's going to be 3 sigma. So then what about the, per, let's suppose its area is a dash, let's say, or else let's say, so fine. So its mass is m dash. So then, so what will be its sigma into its area a dash? Because M is equals to sigma into A, right? For 1 unit it's sigma, for 2 units it's 2 sigma, for 3 units it's 3 sigma, for M dash it's going to be sigma A dash, right? So then can we find the mass of this part? So can we find the mass of this part? Sigma is equals to mass M dash into M dash by A. So from here M dash is equals to sigma into A. M dash is equals to sigma into A. A means, so here A means the area of this one, A dash let's consider. So area of the remained portion. So we already know what is sigma. This sigma is a moment of inertia for the whole disk. So which is nothing but mass per unit area. So here I can write mass per unit area, which is pi r square, whole disk. This sigma is for the whole disk. And what about for this small disk? It's going to be simply pi r square. So pi gets cancelled. So then we have got, so the moment of inertia, the mass of this one, so the M dash is this one, M r square by r square, M into small r square by capital R square. That's it. So this is how we find the mass. You need not to remember any formula, just understand the procedure how we are finding, that's it. So just understand the procedure. So first, what is the moment of inertia of the remaining portion? Complete disk minus moment of inertia of the removed portion. Moment of inertia of the removed portion. So now let's come to the next point. So if we have to, this is the whole disk, and this is a removed portion, so which is at a distance d from the center, and then whose radius is small r, and this mass is capital M, this radius is capital R, and this has the mass M dash, so the area A dash, right? So then the moment of inertia of the complete remaining portion is equals to, so moment of inertia of the complete disk minus, so the moment of inertia of the removed part, right? So chalo, so now understand carefully. So this we already know, this is mr square by 2, the moment of inertia of the complete disk we know, so mr square by 2 minus, so now how do you find the moment of inertia of this part? So this part is at a distance r d, this is actually at a distance d. For the whole disk, we know about this axis. What is about this axis? Sorry, we know about this axis. So about this axis, which is nothing but sorry, mr square by 2. So and about this axis, yeah, take this one. About this axis we know the diametrical axis. Now we need about its center of mass. So now we need about its center of mass. So this distance is d, right? So now we know the moment of inertia of about its axis plus this one, simple thing, mr square by 4 about this axis for the disk. So and again I am applying the parallel axis theorem. So plus what is its mass? Its mass is m dash, and so what is the distance? D square, that's it. So what is its mass? M dash into what is the distance? D square. So this part, how many of you understood, guys? This part, so just check how many of you understood. Any complication here? Any complication? Any complication here? See, or else you can also write this as, this way you can write simply m dash, so its mass into r square by 2 m dash r square by 2 plus, so m dash into, so what's the distance? D square. This way also you can write. Yes or no? The simple one. So m dash into r square. What is the moment of inertia about its center? Its center, it is m dash mass into, so the radius of it r square, so into by 2, so by 2, so plus So it is at a distance for the perpendicular axis. So let me remove this axis. So because we already know about the perpendicular axis, right? So now, so let me take this one. Now you can understand better. This one. If you are taking about the diametrical axis, you can take mr square by 4 plus the m dash d square. So that also fine. But I know already about the perpendicular axis. I took here perpendicular axis. So here also I am taking the same perpendicular axis. M dash r square by 2. So a mass of it, about its center of mass, m dash into what is its radius, r square by 2 plus m dash d square. So here parallel axis theorem. About its center plus at a distance here. That's it. Done this part. So this is just the method. How do we solve? So one we'll take one question so that you will understand even better. Okay na? Clear guys? So all your doubts will be clear. So once I take the question, see here. So now try to understand the question properly. From a disk of radius r and mass m. So from a disk of radius r and mass m. This is a disk. So which is of radius r and mass m. So a circular hole of diameter r. So a circular hole of diameter r, whose rim passes through the center of the center is cut. Whose rim passes through the center is cut. Yeah. So now perfect. See, whose rim passes through the center. Let's suppose this is the center of the whole circle. So then whose rim is passes through the center and diameter, whole diameter r. So its radius will be r by 2. So the whole diameter of the removed portion is r. So its radius will be r by 2 and this whole thing is capital R and capital M. So what's the moment of inertia of the remaining part of the disk about the perpendicular axis, passing through the center, about the perpendicular axis passing through the center. Same concept. The first thing is, so the moment of inertia of the remaining portion is equals to the moment of inertia of the disk, complete disk, minus the moment of inertia of removed part. So the first thing is we need the moment of inertia of the complete disk. So about its perpendicular axis, it's going to be mr square by 2. About its perpendicular axis, it's mr square by 2 minus. So the mass of the removed portion, let it be m dash. So what is its radius? R by 2. So m into its radius is r by 2 whole square by 2 plus its mass is m dash. So and then it is at a distance from the center. This distance again will be r by 2. Yes or no? So it's again at a distance r by 2. So m dash r by 2 whole square. So this part is clear. Yes or no? So now, so how do you find the mass of the remaining portion? First, let's find the mass of remaining removed part. So the mass of the removed part. So which is nothing, this is m dash. So how do we find that? So simply sigma into, so the area A dash, sigma into area of that. So what is the sigma? So the total mass of the ring by, so the area pi r square. So into, so what's the area of this part? Pi into, so its radius is r by 2. So r by 2 whole square, right? So then, so here I can write m by pi r square into, so pi r square by 4, right? So here pi r square. So then its mass will become, so the m dash is equals to m by 4. So its m dash is equals to m by 4 we got. So the moment of the mass of the removed part we know. So simply we can calculate now. So can you guys calculate that? Can you guys calculate that value? I'll just move aside. Just substitute the values. Chalo. So here m r square by 2 minus, so m dash, in place of m dash I can write m by 4 into r square by 4 by 2, right? So plus here this one m by 4, m dash is m by 4, so here it is r square by 2 square is 4. So I can write here m r square by 2, so minus, so this will become m r square, so 16 into 2, so 32 minus, so m r square by 16, m r square by 16. So then next we have, so the moment of inertia of the remaining portion, just do the calculations, is equals to, so what we can write here, so m r square by 2 minus m r square by 32 minus m r square by, here this is m r square by 16. So then I get, so 32 is a LCM, so this goes 16 m r square, so minus m r square, so this is 2 m r square, so which is nothing but 16 minus 3, so 13 m r square by 32. So 13 m r square by 32. So this is the moment of inertia of the remaining part or remaining portion. So is equals to, so 13 m r square by 32. So this is the standard result, guys. So you can directly remember. This is a standard result. Done. So 13 by 32 m r square. Option D is the correct one. 13 by 32 m r square. Clear? Chalo. So let's move further. So then let's take one more question. So what's the question says? So the question number 7. So from a uniform circular disc of radius r and mass 9m, its mass is 9m now. So a small disc of radius r by 3 is removed concentrically. So then the moment of inertia of the remaining disc about an axis perpendicular to the plane of the disc and passing through its center. Same concept. So you can apply the same concept, guys. Here the moment of inertia of the remaining portion is equals to, so the moment of inertia of the complete disc minus, so the moment of inertia of the removed part. Okay, so then I can take, so the moment of inertia of the complete disc is m r square by 2. So but here it is given, so the mass is 9m and radius is r. Yes or no? So its mass is 9m now. So the complete disc moment of inertia will become 9m into r square, m r square by 2 about its perpendicular axis, they said. Right? So minus, so whatever the removed part, so the moment of inertia of the removed part will be, so its mass, let it be m dash into, so what is this one, the radius of that is r by 3, so m dash into r by 3 whole square by 2 plus, so its mass m dash into, so at what distance, which is at a distance 2r by 3. So from center it is at a distance 2r by 3 now. So 2r by 3 whole square, that's it. So now how do we find the mass of the remaining portion first? So the mass of the remaining portion I can find it here. So the m dash is equals to sigma into a dash. M dash is equals to simply sigma into a dash. So what is sigma? So total mass 9m into mass per unit area pi r square, the total one. Sigma is equals to 9m, the total mass, by, so its area pi r square. So into, so what is a dash? So a dash will be, so pi into r square. What is r? R is r by 3 here. The removed part has the radius r by 3. Yes. So from here I can write, so 9m by pi r square into pi r square by 9. So 9 cancel, sorry, 9 cancel, pi r square gets cancelled. So its mass will become, m dash will be equals to m. So then you can just simply substitute the values now. So we get 9m r square by 2 minus, so m dash is m. So here r square by, so this is 3 square is 9, 9 by 9 into 2, 18. So plus this one m dash is m, so into 2r square, so which is 4r square by 9, 4r square by 9, so which is 9 mr square by 2 minus mr square by 18 minus, so 4 mr square by 9. Yes, so you can take the LCM there. So again I am writing the same, 9 mr square by 2 minus this one mr square by 18, mr square by 18 minus, so this part 4 mr square by 9, 4 mr square by 9. So from here, so 18 is the LCM, so this is 9 into 9, sorry, so it goes 2 9 times, so 9 into 9, 81 mr square minus, so it goes mr square minus, it goes 2 times, 2 into 4, 8 mr square, so which comes out to be, so 81 mr square minus 9 mr square by 18, so which is 72 mr square by 18, so which is nothing but 4 times, so which is 4 mr square. So the final answer should be 4 mr square. So the option 3 is the correct one, 4 mr square. Clear guys? Understood the concept? Simple concept, just you have to focus on the concept, then so don't do the calculation mistakes anywhere. Done? Sure. So this is about the moment of inertia of the remaining portion. So now let's go for the concept of tau is equals to I alpha. So let's go for the tau is equals to I alpha concept. So let me derive this part. So let me derive this part guys. So how do we derive this? So let's suppose a particle is moving in the circular path like this upon the application of the tangential force Ft, right? So we know that the torque is equals to, sorry, so we know that the torque is equals to R cross F. So here what type of force is acting? So the tangential force is acting. So I can write the torque is equals to R into, so the force that is, the radius is this one, the force that is acting is the tangential force Ft, and the angle between radius and the Ft is sine 90 degrees. So sine 90 degrees I am writing. So the torque is equals to R into Ft, because sine 90 is 1, right? So then torque is equals to here R into, so I can write what is Ft. So in place of Ft, so shall I write mass into the tangential acceleration, mass into, so the tangential acceleration. So then therefore R into, so m into, so in place of tangential acceleration, shall I write R alpha? You know that the tangential acceleration is equals to R alpha. Yes or no? We already discussed about it in the circular motion and also in rotational motions first class, right? So from here, so I can write, so the tau is equals to, so R into m into, so or else I can write, so m, let's write first, into R square m into R square into alpha. So shall I write here in place of mr square, so the moment of inertia I, so therefore the torque tau is equals to I alpha. So don't write any vector form, just let it be. So the torque is equals to I alpha, tau torque is equals to simply I alpha, that's it. So remember this. So you can also remember it with the analogy. So what's the analogy? So between the linear terms and angular terms, see, be active guys, you already know all these concepts, okay? So the linear and angular terms and their relation also you know. So in the linear terms, so we know the displacement here theta, so here the velocity, linear velocity, here the angular velocity, here the acceleration, tangential acceleration, and here the angular acceleration alpha, and here the mass, whatever the role the mass plays, here the moment of inertia, here whatever the relation that the force plays, so here the torque plays, right? Yes or no? What's the relation between theta and s? So s is equals to r theta we know, and v is equals to r omega we know, right? And then the tangential acceleration at is equals to r alpha we know. So and then moment of inertia and mass I is equals to mr square we know, and then so tau and f, so tau is equals to r cross f we know, right? So and now one more relation between tau and the angular acceleration, so that is tau is equals to I alpha. So this relation also you should remember. So the tau is equals to I alpha. Clear? Understood guys? Tau is equals to I alpha. So this is one more relation you guys should remember. Done. So this is simply like F is equals to ma. So whatever the role that the mass plays in the linear motion, so now the moment of inertia is placing here. Here acceleration, linear acceleration, here angular acceleration, here linear force, here the rotational force torque. So the same role mass, whatever the mass plays, here the moment of inertia plays. Done? So remember this formula. So now let's go for the questions. Let's take some questions guys, the simple questions. So find the angular acceleration of the disk of mass 10 kg, radius 20 centimeters at the instant when the force is applied tangentially as shown. So find the angular acceleration. So we have to find what is alpha. So we have to find what is alpha. So force I know and radius also I know. This is the radius which is 20 centimeter. So this whole mass is 10 kg. So first let me do one thing. So let's find the torque using the formula R cross F. Let's find the torque using R cross F. So what is radius R? So it's a 20 centimeters. So 20 by 100 I am writing. So radius into force. So radius and force are perpendicular here. Force is 20 newtons into the sine 90 degrees because they both are perpendicular. So here 0, 0 cancels, sine 90 is 1. So it is 40 by 10. Yes or no? So this is 40 2 times. Yeah. So 40 by 10. So which is 4. So the torque we got it as 4 here. So then similarly, so shall I find the torque using the formula I alpha? The torque using the formula I alpha. So they said it is a disk. So it's a disk. So therefore torque we already got, which is 4, which is equal to the moment of inertia of the disk is mr square by 2. So now shall I find the value of alpha, because the only unknown is alpha. So 4 is equals to this one. Mass is 10 kg. Radius is what? So 20 by 100 whole square, right? So into, so 1 by 2. Yes or no? So whole square mass into r square into, let's write 1 by 2. So into alpha. So 4 is equals to, this is 10 into, so it's going to be 0, 0 cancel. So 0.2 whole square, right? So into, or else let's write this way. So 2 square is 4 by, so this is 100 into, so 1 by 2 into alpha. So 4 cancel. Let's send this 100 to this side. It will become 200 is equals to 10 into alpha. So this is alpha is equals to 20 radian per second square. Yes or no? So alpha is equals to 20 radian per second square. Option 2 is the correct one. Simple calculations. Done guys? Clear? So let's go for the next question. A rope is wound about a hollow cylinder of mass 3 kg and radius 40 centimeter. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 newtons? So let's consider the hollow cylinder. See, the cylinder is inwards now. I am taking the cylinder this way. So only the circular part is visible to you. So the cylinder is like this, inside, like this. This is a cylinder. You just consider this is a whole cylinder. You are able to see this circular part. So about this circular part, a rope is attached here. So here they attached a rope. Okay. So now this cylinder is of mass 3 kg and whose radius of this circular cross section is 40 centimeter. So now they pulled it with a force of how much? Pulled it with a force of 30 newtons force they applied. Now they are asking what is the angular acceleration. Same thing. So let's find the torque first. So the torque is equals to R cross F. So what is the radius? 40 centimeters. So 40 by 100 into, so the force applied is 30 newtons. So you can see here the radius and the tangential force are perpendicular to each other. So which is sin 90. Let it be aside. So then let's write the torque formula. We know one more torque formula. So which is I alpha. So right. So in place of torque, shall I substitute this value? 40 by 100 into 30. 40 by 100 into 30 is equals to sin 90 is 1. So I is what? Moment of inertia of the hollow cylinder. So where is it? Hollow cylinder means same as of the ring. Hollow cylinder means same as of the ring, right? So simply you can substitute mr square. So the only unknown is alpha now. So simply substitute the values, guys. So 40 by 100 into 30 is equals to mass 3 kg, radius 40 by 100. So radius 40 by 100 whole square, right? So into alpha. So now do the calculations. So here 40 by 100. So we can here also 40 by 100, right? So 40 by 100, 145 by 40 by 100 cancel. So 3 ones are, so 3 tens are. So 10 into, send this 100 to this side. So 10 into 100 is equals to 40 into alpha. The only for 0 0 cancel. So this is 100, which is equals to alpha. Sorry, 4 alpha. So alpha is equals to 100 by 4. So 25 radian per second square. The angular acceleration they asked. See here in the options we have 25 meter per second square, 25 radian per second square. Which one to choose now? So the option 3 is the correct one, guys. Don't take the option 1. So in the so most of the times the examiner to make you confused, so they'll give 25. So after seeing 25, so we don't bother about what are all the other options. Hey, I got 25, I'll put 25 meter per second square. So after coming out of the exam, I did every question correct. Pakka. That moment of inertia question is there, na? So that finding angular acceleration, that to pakka. 4 marks pakka for me in that question. But the reality is you have chosen the wrong answer. Okay. So just joking, but most of the students, they get excited when they get the answer. So that's a good thing, but check all the remaining options also and choose the relevant answer. So if the same values are there, magnitudes, check the units also. And sometimes direction matters. Understanding, guys? Chalo, sometimes sign matters. All these things you have to take care. Okay. Chalo, so NEET 2016 question. So what's the question says here? A wheel of radius 10 centimeters can rotate freely about its center as shown in the figure. So it can rotate about its center 10 as shown in the figure. A string wrapped over its rim is pulled with a force of 5 newtons. Fine. It is observed that the torque produces an angular acceleration of 2 radian per second square. So angular acceleration is also given. What is the moment of inertia of the wheel? So we don't know what type of wheel it is, whether it is made up of the disc or solid cylinder or hollow cylinder, we don't know that. So we have to find its moment of inertia. So same thing, you can find the torque, so using R cross F, and then you can find the torque using I alpha. So let's equate those two. So we have got R cross F is equals to I alpha. So now what is R? Radius is 10 centimeters. Is it the diameter or radius? Radius only. So 10 centimeters. So 10 by 100. So this will be the radius. Yes or no? So force, how much force they applied? 5 newtons force. So force is tangential and radius is here. So both are perpendicular. So 90 degrees, sin 90 degrees. So and I, moment of inertia we have to find, and angular acceleration 2 they gave. So simply, so here 2 ones are, 2 5s are, 5 into 5, 25. So 25 by 100. I is equals to 0.25 kg meter square. So did you guys remember the units of the moment of inertia? Kg meter square, mr square. So 0.25 kg meter square. Simple question again. Done, guys? Clear? Chal. So let's move further. So the next question. A solid cylinder. Whenever they say solid cylinder, you can consider its moment of inertia is same as of the disk. Whenever they say hollow cylinder, you can consider its moment of inertia same as of the ring. Okay, so remember that point. So this is of mass 50 kg, radius 0.5 meters, is free to rotate about the horizontal axis. So about its horizontal axis. So what about its horizontal axis? Like this one, about its axis. This is a cylinder, it's free to rotate about its horizontal axis, means you have to imagine the cylinder like this. About this axis, we already know the moment of inertia. Yes or no? So then, so next, a massless string is wound round the cylinder, so with one end attached to it and other hanging freely. So the tension in the string required to produce an angular acceleration 2 revolutions per second square. Here also, so take care guys. So the 2 revolutions per second square. So here alpha is not 2 revolutions per second square. Angular acceleration is 2 revolutions per second square, but this is not the alpha, revolutions per second square. Alpha should be radian per second square, right? Alpha should be radian per second square. Here is a complexity lies in this question. So logic point. So for see in 1 second, so it's going, so 2 revolutions per second. 2 revolutions per second square means, so we already know that the theta is equals to n by 2 pi. The angular displacement is equals to theta is equals to n by 2 pi. So then from here, can we find, sorry, number of revolutions, my bad, sorry. The number of revolutions is equals to theta by 2 pi. Now, can we find, so what is the total theta here? N into 2 pi. For each revolution, it makes 2 pi, right? So then, it's already making 2 revolutions. So 2 revolutions means 2 into 2 pi. So 2 revolutions means 2 into, so again this should be, so what is n? N is 2 revolutions per second square, right? So 2 into 2 pi. Yes or no? So 2 into 2 pi. So which is nothing but 4 pi is a theta, guys. 4 pi is the theta. So just try to understand the given question. So we have to find the tension. Tension is nothing but the force we have to find. Okay. So it should be 2 pi revolutions in the question. I guess they gave it wrong. So let's check the options. So I guess it should be as far as my knowledge concerned, this question is a previous year question. So this should be pi only. So let's take pi. If you don't get, then we consider 2 only. So 2 pi revolutions per second square. So now theta we got. So then see here, it is free to rotate about the horizontal axis. A mass is so fine. So one end attached to the another end. So fine. So we have got theta. So can we find the torque is equals to R cross F, and then the torque is equals to I alpha. The torque is equals to I alpha. So now fine. So the tension in the string to produce an angular acceleration of 2 pi revolutions per second square. It is free to rotate initially. Fine. So R cross F, tau is equals to what is R? 0.5 into, so what is F? What is F? The force. So we have to find that force is nothing but the tension force. So then here torque is equals to I, moment of inertia of the solid cylinder. So solid cylinder is nothing but simply mr square by 2. So into, so here the alpha, so we have to take, I guess some information is missing in the question. So just let me go and check, guys. So just a minute. Just hold on, I'll check the information from the textbook. Yes, guys. So the question is correct only. So my bad, actually. Yes, it's not 2 pi, it's 2 only. So I thought it's 2 pi in the question. It should be. So it's 2 pi only. So the same concept, whatever I explained. So theta is equals to theta, n is equals to theta by 2 pi, right? So from here, so what is the total angular total alpha? So the alpha will be equals to 2 pi see here, 2 revolution per second square. So for 1 revolution it's 2 pi, right? So now for 2 revolutions it will be 2 into 2 pi, so which is nothing but 4 pi 4 pi per second square. So alpha we got. So now you can apply the same formula. Tau is equals to r cross f, and then same tau is equals to I alpha. So from here r cross f is equals to I alpha, you can take r cross f is equals to I alpha, you can take simply. So now what's the concept? R is radius 0.5 meters. So the force is nothing but the tension here. So the force is with which you are pulling it down. So that applies the same tension, right? Force is equals to tension. So into, so that they both will be perpendicular, sin 90. I is what? So the moment of inertia we have to find a, no, they gave. So for this one, the moment of inertia is mr square by 2 into, so the angular acceleration alpha we know. So what is that? 4 pi. So now simply substitute the values. So this is 0.5 into the tension T into sin 91 is equals to mass 50 kg into radius square. So which is 0.5 into 0.5 by 2. So into 4 pi into 4 pi. So now let's do the calculation, guys. So from here I will get here 1 0.5 cancel. So the tension T is equals to, so here 0.5 into 5 25 by 2 into 4 pi. So this is 100 pi by 2. So which is 100 into pi is 3.14. So by 2. So which is 314 by 2. So 2 ones are 1 2 5s are, so 7. So 2 7s are. So 157 newtons is a tension. Clear? Sure. So that's a option 4. Clear, guys? Understood? So how this here is a logic, 2 revolution per second square. I thought 2 pi, so but it's 2 revolutions only. Correct only question. So for 1 revolution it takes 2 pi, right? So total distance. So for the alpha will be for 2 revolutions means 2 into 2 pi. So which is 4 pi per second square, the alpha. Clear? So the next question. So this is a simple question, very simple question. The instantaneous angular position of a point on a rotating wheel is given by the equation. So instantaneous position means theta is given. So theta t is equals to 2t cube minus 6t square. So they are asking the torque on the wheel becomes 0. So if the torque is 0, so torque is equals to I alpha. So moment of inertia can't be 0 for the wheel. So the alpha should be 0. If the torque is 0, so the alpha should be 0. So find alpha. How do you find alpha? So you can find omega first, which is d theta by dt. So which is d by dt of, so what is the theta? So 2t cube minus 6t square. So here it's going to be 6t square minus 12t. This is omega. So then can you find alpha, which is d omega by dt. So d by dt of omega is what? 6t square minus 12t. So which is nothing but 12t minus 12, right? So now alpha you can equate it to 0 because the torque becomes 0 means alpha 0. So alpha 0, so which is 12t minus 12 is equals to 0. So 12t is equals to 12, and then t is equals to 1 second. 1 second. Option 2. Clear? Understood, guys? Chalo. So remaining questions you can take it as a homework, same type of questions. So this question is also very easy question. Take it as a homework 1. So I'll give 4 questions for the homework. So this question also homework. So take it as a homework 2. And then, so this question is also the pretty easy question. Homework 3. And then this one homework 4. Clear? Understood, guys? So try these 4 questions. In the next session, I'll solve these 4 questions and then I'll go to the next concept. So till then, keep studying. All the very best. Bye. Take care.